Hi everyone, it's Alice here from Top Mark Science, and today we will be looking at balancing equations. Throughout this video, we will be exploring the conservation of mass, whether chemical formulae equations are balanced, and balancing our own equations. Let's get started. I'm sure that you've seen balance in your everyday life, in the play park, at the gym, playing games, everywhere. Balance means to have an even distribution of something, and we're going to look at this in more detail at how it can relate to chemistry. Take this 100-gram bar of chocolate, for example. If we melt it, can we end up with 200 grams? Does this work? Unfortunately not. We cannot just gain 100 grams randomly out of nowhere. The 100 grams of solid chocolate melts to end up with 100 grams of melted chocolate. There is an even distribution of matter before and after the change has taken place. This is the conservation of mass, which says the mass of products before a reaction must equal the mass of reactants. There is no change in mass, but there may be a rearrangement of atoms. Let's look at some examples. We won't dive into the chemistry just yet. Are the fruits balanced on the left and the right side of the arrow? No. If we divide them up, identify our reactant fruits and count them, I have one apple, one banana, one orange, and one strawberry. If I repeat for the product fruits, I have one apple, one banana, two oranges, and one strawberry. My oranges are not in balance. I have one orange on the left and two on the right, so I need to figure out a way to make them the same. I know that 1 goes into 2 twice, so I multiply my left oranges by 2 to give me 2 oranges. Now everyone's happy and in balance. Are these balanced? Yes. I have an even distribution of all fruits on both sides. Okay, enough about chocolate and fruits. Let's see how we can apply our learning so far. Pause the video here and identify what is wrong with this equation. The challenge is to think of a way to solve it. Let's see what we came up with then. Remember, our conservation of mass means we should have the same in our reactants and products, but the atoms may rearrange themselves. Time to get counting. Split these with a line under your arrow. Identify your elements present and count their number of atoms. In my reactants, I have 2 hydrogens and 2 oxygens. On my right, I have 2 hydrogens, but only 1 oxygen. Comparing both sides shows my hydrogens are the same. They are balanced, but oxygens are not. I'm going to think now of the lowest common factor of 1 and 2. That's 2. So I multiply my 1 oxygen by 2, which means I will now have 2 molecules of H2O. To show this in the equation, I place the 2 at the front of the molecule or compound containing the oxygen I am interested in. You should never add little numbers at the end of formulae. This 2 at the front indicates that there are 2 of everything that comes after it. So 2 lots of H2, which now gives me 4 hydrogens and 2 lots of oxygen. After a recount, my oxygens are now balanced. But my hydrogen has now changed to a 4 and the other side is 2. I know that 2 goes into 4 twice, so I can multiply this side now by 2. I place the 2 in front of the H2, which means I have 2 molecules of H2, shown like this. Have a little recount. I have 4 atoms of hydrogen now. Now we are balanced. So if I strip this back, we can see the final equation is 2H2 plus O2 makes 2 lots of H2O. Let's go through another example before some independence. Here I have 2 Mg plus O2 makes MgO. I will show you how to balance this. Separate your reactants and products first. Identify the elements present in your reactants and products. Then count them on both sides. Magnesium is not balanced and neither is oxygen. I'm going to think of the lowest common factor of 1 and 2. We can multiply this whole side by 2 in this case. I'm going to place this 2 in front of MgO to show that I have 2 magnesiums and 2 oxygens. These are now balanced, and so are my oxygens, to leave me with this final balanced equation. Pause the video here and use the method we have just gone through to give these a go. I have placed some boxes in the positions there should be numbers. If you finish these, try the challenge which do not have boxes. Well done for giving these a go. Let's go through our answers. So we've already done the top one, so we know these boxes should be filled with a 2. Let's go through the next one. H2 plus Cl2 makes HCl. Identify and count my reactants, elements and atoms, and same for my products. I need to multiply this side by 2, and that 2 goes in front of HCl to give us this balanced equation. Follow the same method for the next question to give you 2 and 2. And I'll go through this one in detail because there is an additional feature, the brackets. Following the same steps, I identify and count. So I have 1 calcium this side, 2 hydrogens, and 1 oxygen. And over here, I still have calcium, hydrogen, and oxygen. I have 1 calcium. But now these brackets mean I have whatever is inside the brackets multiplied by the number on the outside of the brackets. In this case, there is a number 2. So I have 2 lots of 1 oxygen, which is 2, and 2 lots of 1 hydrogen, which is also 2. And finishing off with another 2 hydrogens, so this brings me up to 4 hydrogens. Counting up both sides shows calciums are in balance, but the others are not. I'm going to aim to balance out the hydrogens first, where on one side there is 2 and the other is 4. So I will multiply my reactants by 2. Place that 2 in front of where my hydrogens of interest are and recount. These are now happy, and so are my oxygens, leaving me with this equation. Now for the challenge without boxes. Follow the same steps of splitting up, identifying and counting on both sides. I'm going to multiply this set of hydrogens by 2 to bring them up to 4, like the reactants. Place that 2 in front of H2O and recount. It's changed the oxygens in this case. So I can multiply this set of oxygens by 2 and place that 2 in front of O2 and recount to give me 4. They're balanced to give me this final equation. Following the same methods as the others, you should have arrived at these balanced equations for the other challenges. If you have more time and would like more practice, pause the video here for some more questions and challenges. If you tried these additional questions, let's see how you got on. Answers are on the screen. Pause the video for more time to mark them. Well done for giving them a go if you did. Time for our end of video quiz. Question 1. The conservation of mass means that the mass of the reactants and the products are different or the same. They are the same. Question 2. What do we call it when we want to make the number of atoms the same on both sides of an equation. We can call this balanced or balancing equations. Nice work! Question 3. True or false? When placing a number to balance an equation, we add little numbers onto the end of chemical formulae. This is false. You must never put numbers at the end. You must put the number at the beginning. Never mess with the little numbers when balancing equations. Question 4. What does the number in front of molecular formula mean versus number after brackets? For example, 2MgO versus Mg brackets O2. In front of the formula, you multiply everything after that number in the formula by that number. For example, 2MgO means 2Mg and 2O. After the brackets, only the atoms in the brackets are multiplied by the number outside the brackets. For example, Mg brackets O and 2 is 1Mg and 2O. And final question, balance this equation. H2O makes Hg plus O2. We should have 2 H2O, 2 Hg and O2. Now that we're reaching the end, rag your process to see what we still need to work on. It's always good to know where our areas of strengths and development are. Thank you so much for watching this video, guys. If you enjoyed this video and would like to see more from Top Marks Science, you can like this video and subscribe to this channel. I'll see you next time.